Welcome back, everyone. The garbage gods have smiled upon me, and we got a microwave here that we're going to be doing a post-mortem disassembly on, and we're going to be using a few parts to build a fractal burner or a Lichtenburg pattern burner, which will give us these kind of burns on wood. So let's get started. We see our autopsy professional, Dr. Moeller, approach the patient and takes no time in getting into it. Look at that, he's just ripping this thing apart. After removing some of the connective tissues, he will peel back the scalp and show us the inner workings of a microwave. As a final inspection to make sure he has gotten everything. And there it is. Marvelous work. He now removes some final skull fragments and prepares to remove the meninge membrane. There it is. Well done. And now over to Dr. Moeller. Here's a thermocouple. This is to sense the heat of the Magnetron in case it gets hot. This thermocouple here is to sense the heat inside the chamber. If it gets too hot on either one, it'll shut down the system, keeping it from catching on fire. There's our thermocouple. Usually there's a temperature rating on them. This one doesn't say, but it does have a number, 125 LR2. You look that up online and get the temperature rating. It's probably 125. Let's pull out this other thermocouple. And here's the other one. Let's take it off this mounting bracket and see if we can get a number on it. This one is 35 LR1. So I'll have to look these up and see what the temperature ratings are on them. Those are worth keeping. Now here we have a small fan. This cools the Magnetron. So we'll see if we can pop that out. So we're going to have to loosen up the Magnetron before we can get in there to get the fan out. Piece of steel. Probably won't use that for anything. I really want to save this light. Hope it doesn't break. Even had a piece of epoxy on it to hold the light into the socket. 125 volt. Don't know what I'll use it for, but it looks cool. And that's what counts. Let me get a pair of wire cutters. Okay, found a pair of wire cutters. No, that's too big. Need to use the smaller wire cutters. Take off these tie strips, these tie downs, so I can get the wires out. Okay, white and red. Go to the light bulb, so we'll cut those and try and figure out how this socket comes out. It comes out very easily. Okay, light bulb socket. What's interesting is you take the light bulb, you screw it into the socket, you actually have a matched pair. Odd how that works, but okay, let's get back to it. Still got some tie downs here. Alright, the fan should be able to slide out now. Piece of metal here that we got to bend out of the way so it'll pop out. And we'll unplug the fan. It's got just a couple of spade connectors. We'll unplug it using these side cutters here. These connectors on the side that connect the wire to that plastic are notorious for tearing out when you try and pull the wire off of it. This is a shaded pole motor. It uses induction through this coil to set up a magnetic field through this iron core. That magnetic field oscillating back and forth induces a back EMF into this rotor, which causes the fan to spin. And this little copper loop here causes a slight retardation of the magnetic phase on this side to give it a difference, so it doesn't just sit here and hum back and forth, it will actually spin. This is a very low current motor, low starting torque, really not that efficient, but it does the job. You just want to move air. Now we'll get to the magnetron here. The thing about the magnetron, it's driven by this capacitor and this transformer. We want the transformer. The capacitor, if it's still charged and you get across it, it'll knock your ding-dong in the dirt. It carries a lot of oomph. So let me get something to short that out. Okay. Capacitor's kind of hidden back in here. So we'll get across the poles, the terminals, and short it out. And nothing. That's good. Now I can detach the magnetron. I didn't want to grab either one of these connectors because they're connected to the capacitor. So we'll unplug this and unplug this. Now there's two donut magnets in here that are very strong. I want to get those out. There's also these aluminum fins. I put those in my scrap aluminum and melt them down and make something good out of them. And there's also some wire in here, some copper wire. If you're a scrapper, you'll want to pop it open and get the copper wire out. Now, one thing about these magnetrons, there's a part in here that's made out of beryllium oxide. If you break it and you liberate the beryllium oxide into a dust, then and if you inhale it, it'll give you berylliosis. Basically, it'll kill you. This is a brass screen. You can pull that out. Set it aside. Pretty useless for anything I have going on here. Now here's the beryllium right here. This little white shaft sticking up. That's beryllium. It goes all the way through, comes out in the back here. So in this one it's kind of shaded pink. Some of them are white, some of them are pink. That's the part to look out for. There's a couple pieces of copper here. We'll snip those off. We can use copper for pulling our silver out of solution. Use copper. The copper mixes with the nitric acid and creates copper nitrate, knocking the silver out of solution, bringing the copper into solution. Now it does have an iron core in the center here,
So you stretch out the copper and pull out this little piece of iron or ferrite. That goes for both of them. Just grab one end and pull, and you'll see it pop out in the middle here. Give it a bend and pull it out. And we got two pieces of copper. Of course, they have lacquer on them, so I'll probably soak them in hydrochloric acid or maybe sulfuric acid, see if that'll take the lacquer off of them. It should. If not, I'll dip them in nitric and take the lacquer off that way. Something will take it off. You know what? I'm going to pull out one of the magnets. Pulling out the top magnet is no big deal. So you just need to peel this side open. If I had the right tool, it'd be easier. Be back. Okay. I am back. So we get in here with this Magnetron disassembly tool, aka screwdriver, and we just start prying. Now there's scrapper channels out there that show how to disassemble these. Their processes are much more refined than mine. They have a quicker way of doing things. They know what they can bend, what they can break. So there you go, pry this apart. Be careful you don't break the beryllium. Another piece of steel. Got a retainer on the top here. Got a crimp on it, so I'll have to pull it off the crimp. There we go. Both pieces of steel. And this magnet slips right off. Got a really strong magnet. Once you get the magnets apart, you got to be careful that you don't get them close to each other with your fingers between it. They'll snap together and pinch you. Wouldn't really hurt you too much in the long term, but it would be a momentary shock and probably hurt you for a couple of days. Okay, now we just lift out this section here. This is your beryllium, this is your aluminum. You want to get the aluminum off the beryllium. Now this is the core of the magnetron, this beryllium unit. That and the high voltage generate a frequency in the 2.4 gigahertz range, and that will cook your food. Yeah, 800 to 2000 watts. So just about got all this out. And there we go. Now inside here is another coil of wire. Some people will cut this open, pull it apart, get the coil out. I'm not going to do that because I don't want to take a chance in breaking the beryllium. That would be a bad thing. Okay, here's the other magnet. Let's see if we can put them together. Okay, we got them reverse poled, or like poles. Ooh, shit. So you can see it. They will pinch you. Now let me show you a trick here. This is a stick. It goes up. So it's a stick up. We'll put one magnet down here at the bottom. Place another magnet on top. and I've got them backwards. So if you put them like pole to each other, they'll repel. And you'll have yourself a suspension. So one magnet will hold up the other. Looks a lot cooler on a stick that's a little bit bigger in diameter, because this one the magnet wants to tip sideways on it. But that's my big trick for the day. Hooray. Okay, we'll set that aside. Set our aluminum over here. More steel. Now for the prize. Got this big transformer right here. Got some wires going across it. So let's pull those out. Okay, we'll just cut you out then. Off the neutral from this little board in here. There we go. Pull this strain relief through, and we've got ourselves a nice power cable with terminals on the ends already. We'll need that. We'll put you over here. Okay, time to get to the nuts and bolts of the transformer. I'm a bit surprised. This must be an old microwave, because it doesn't have any safety screws or anti-tamper screws on it. Most of them nowadays do. That wouldn't stop me though. Kidoki, come out wherever you are. Come out, it's time to play. Okay, we got some wires here holding us in. That wire there is important. That's the output for the high voltage. We've got the low voltage leads on this side, or the mains, the 120 volt. Come on off. Nut brake. Okay. Those connectors are kind of on there well. I don't want to tear the transformer apart to get the connectors off. There's our transformer. That's 120 volt, 60 hertz input. The output, this side, is 2000 volts. That'll kill you. It's got enough current behind it. It's got enough voltage. Now the voltage, what it does is it breaks down the skin resistance. It's the current that kills you. Well, this will put out probably a half an amp at 2000 volts. Skin resistance will protect you from, you might start feeling 12 volts, 24 volts, you'll get a tingle, 30 volts, you'll probably feel. Anything above that, you'll start knowing it. 2000 volts, you won't know anything because it'll just kill you. So we have to be careful with this thing. We'll be putting safeties on our system to make sure that I don't nuke myself. Nuke, get it? Anyhow, these wires here, these white wires with the black casing on them, this is a low voltage stage in the transformer. This gives you power to drive your control circuit and your timer up front here. we won't need those, so we'll just cap those off. In fact, we'll just cut them off so we don't have to worry about so much wire. We'll cap them later. But that's the prize. That is what we'll be using to power our Lichtenburg wood burning, or fractal wood burning as some people call it. But I don't know why they call it fractal wood burning. It resembles a fractal, but it's not a fractal. But anyhow, that's our baby. We'll be working with him in a bit. Get some of this other stuff out of the way. I like saving these wires. They have really good connectors on the ends. They're decent wires. Okay, now we'll go for the capacitor. We have discharged it, so it is safe. There's a mains board. It's got a 20 amp fuse in it, a choke coil, a couple of filter capacitors. And I'm wondering if this microwave went out because the fuse blew. That would suck. Hang on just a second. Okay, got our little ohm meter here. Okay, connecting the probes. You always want to test your meter before you use it. If you're testing voltage, like wall voltage, turn it on to 120 volts AC, plug it into the wall on a known good socket, get a reading first, then test your equipment or whatever you're going to test. Okay, we're going to go across our fuse here, and it gives us a reading of 0 ohms. That means the fuse is good. The element across it inside is still intact, conducting the full voltage across. So that wasn't the problem. Could use this board, but I probably won't. It's got a coil in it if you want to cut that off and strip it down for copper. Your equipment may vary. Different manufacturers, different processes of building stuff. Okay, here's our capacitor. This capacitor, in conjunction with this high voltage, low current diode, creates a voltage doubler circuit. That means the 2000 volts coming out of the transformer get to the magnetron at a 4000 volt level. So it can do you some damage. Got kind of a cool little bracket on it. I think I'll leave that on. The label on this capacitor says that it is, well, it says there should be a bleed resistor on here of 10 mega ohms. I don't see a bleed resistor unless it's on the control board somewhere. It's a 0.94 microfarad capacitor, 2200 volts AC, made in China, and it says on it HV danger. So yeah, be careful of them. Most cases, if you're not using them, you can take one of the connectors and jump it over to the other side. Sometimes static electricity can cause these things to build up a charge just sitting around. You don't want to be the one that gets surprised. Well, we got a couple of door safety micro switches here, and then we have our control board up here. It's got a transformer on it, some little diodes, nothing much to speak of. Oh, there's another micro switch down here. So this must be, these are the button and door interlocks. If the door is open and the button is depressed, it shuts the system off. I don't know if I really want to save those. They're inexpensive. And they don't really have a good application in a mining environment. They are susceptible to dust and dirt, water. Okay, here's your safety interlock switches. Got 1, 2, 3, and 4. So they might be good for something. Pull them off this piece of plastic and keep them on hand. Okay, switches. They'll go in our pile. Sort through that later. So this is what we got out of the system. Got our transformer. Got that bad old beryllium thing, beryllium oxide. Got some micro switches. 2 cool magnets. A crap zappator, because it'll zap the crap out of you. Is our mains filter board. Got a pile of steel scrap. Pile of aluminum scrap. Got a nifty little coil. Got a bitchin' light bulb. Got a pile of screws. And a couple of thermal overloads. And a bitchin' awesome fan. A pile of wire. And that's about it. We got that steel scrap laying around here that we'll have to get rid of also. So that's about it. Got some cool stuff out of it. Some usable, some not. Salvage, scrap, whatever.
Well, that's it for today. Join us on our next video. We'll be putting together the Lichtenburg wood burning system and giving it a try out, see what we can burn up. Until then, have fun.